That and that. There we go. Here we go. Two linear equations. What is blue line? That's the equation. What is the blue line? No, don't. The other line doesn't exist yet. Yeah. What is blue line? Okay, it's a line. What does line represent? That's how you create a line. Literally, that is the postulate for how you form a line. You're really overthinking this. Example. If I put the number 5 in there for x, I would get a 9 out. 5, 9 is a coordinate that will... Okay, it's on the line. Oh, man.
An equation.
How long ago did y'all do algebra?
3.
Okay. A line is a set of all solutions. It's everything that's going to make the equation true. I can put pi in there. 2 pi minus 1 is the y that goes with it. Every single point on a line, on any graph, is a coordinate that makes it true. A pair of x and y's that make it true. Blue line, all of the solutions for blue equation. I have to make it a line because there's an infinite number of them. If I said that 2, 3 is a solution, well, what about 1.99999? I could plug that in, I could get a y out with it, right? What is yellow line? Everything that is a solution for yellow equation. What is purple dot?
The solution, the intercept. It is intercept.
Oh boy.
It's been a while.
Okay, somewhere in there I heard like 5 people kind of mashed together to get the answer. A graph of an equation is all the solutions that'll make the equation true. So when I have the graph of one equation and the graph of another equation and they happen to intersect, that is the point or points that will make both of them true. So far we have only done that with lines. But then now we're going to do it with parabolas, having done all this work with quadratics. It's pretty simple. Either the line can completely miss. Okay, think parabola. Person's head. Line. Movie bullet. Boom. You missed. No solution. There is no intersection between them. One solution. Bullet graze. Movies like that, right? The little, you just get that little tuft of hair fly off. Okay? The bullet graze is when it happens in one specific spot. And it's really hard to do because the line has to be perpendicular at that point. So if I make another line that bullet grazes in one spot, it's perpendicular to the graph at that specific spot.
Perpendicular or perpendicular?
The distance between them, 0. Perpendicular with the intersectional point parallel to the slope at that point. And it's really hard to do that because right there versus right here versus right here, yeah, they're all going to have really different equations, aren't they? Because they're curling along that. But if it intersects at exactly one point, this little bullet graze, it is a possibility. Most of the time what we're going to see is, got him. Yeah, it goes through. Okay? 2 solutions. So we're either going to see 2, 1, or none. In order to see it, you got to graph it. Do you remember how to graph a parabola?
Yes.
We've been in this chapter for, what, 3 weeks? Graph it. I ain't going to do it yet. You graph it. Graph the parabola, graph the line. Where do they cross? This is also why we don't want to be lazy with our graphing. This is why you want to use as many points as possible, because odds are one of those points is going to be the intersection. So do you remember how to graphify?
I knew over. How do you know that? So this. Yep.
Come on now. How do you graph parabola? You can complete the square to turn it into vertex form. You can factor it to find your zeros, and then find the axis symmetry that is halfway between them. You can do the old negative b over 2a business to find your axis of symmetry. There are ways. You got to find the one that works for you. Hey, what happens when you run into this exact thing on ACT? Do you remember how they work?
No.
Okay, back in the day, and by back in the day I mean 3 weeks ago, negative b over 2a got me an axis symmetry. X equals 5 halves. Plug 5 halves in to get the y value that goes with it. So at 5 halves, or 2.5, 49 fourths, or 12 1/4, I got a vertex. From that vertex, I'm going to use my a value to create perfect square steps. Which direction?
Down.
How do I know?
Because it's negative.
Negative a value means it's reflected downward. There's a -1 in front of it, so I get to use regular perfect square steps. I don't have to multiply them by anything. So from that point, I will go right 1, down 1, right 2, down 4. What's that? 1, 2, 3, 4. Right 3, down 9. Right 4, down 16. 7. I will mirror them across my axis of symmetry. There, 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 and there. I'm drawing sideways. What other point can I put on there? From the original equation, what's really, really, really easy to find?
The intercept.
Intercepts, right? I can find x and y intercepts. X-intercept, put 0 in for y, solve. In that case, I would have, if I brought everything over to the other side, x squared minus 5x minus 6 is 0. X minus 6, x plus 1. So x is 6 and -1. So that means I'll have a dot at -1 and at 6. What if I plugged a 0 in for x? What would happen? Plug a 0 in for x, and you get y-intercept of 6. So I can put a dot there too. What if I didn't want to do any of that, and I instead said, you know, I remember complete the square, because we just did it last week. Y is negative x squared minus 5x. Remember, I factored out my negative. I leave a space for my complete the square number. Shove 6 off to the side. Say, what is half of -5? It's -5 halves. -5 halves squared is 25 fourths, so I will add 25 fourths here. But I didn't really add 25 fourths. I subtracted it. So I need to add another 25 fourths in order to balance it out. Right as a perfect square, simplify. Oh, hey, look, I've got transformation or vertex form. Now I can find where my vertex is, 5/2, 49/4. With an a value of -1, head down from there. Option 3. Doesn't say how to graph it. Dump it in your calculator and get points. Go to y equals, Claire, well, say -x² plus 5x plus 6. If I graphify, it's somewhere up there. But I can calculate my maximum. That appears to be somewhere between there and 9. As long as they're pointing in at it, it doesn't matter. As long as it sees the x value, it'll give me the y. Oh, look at that. 2.5 or 5/2, 12.25 or 49/4. And then make sure my table is back over to auto. Start plotting points. Okay. So there's a bunch of ways to get your graph. I just care that you get your graph. It's very important to have as many points as possible. All of the points that I made, because my vertex was kind of weird, because it had fractions, all of the points that I made, except for my x and y intercepts, are all at fraction values. Those aren't fun. But the more that I put on there, the more accurate my curve is going to be. So now, when I come along and put this line on here, start at 6, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Now I see exactly where it hits because I've got enough points to make it obvious. It's going to hit right there at 0, 6, and it's going to hit over here at 4, 10. Okay. Do you remember how to graph things? Okay. I hate saying this because not everyone's going to just absorb everything perfectly. From this point forward, you have now done parabolas. You have worked with quadratics graphically, in tables, and algebraically in 2 different classes. You have spent, depending on scheduling, something like 4 months of your life working on quadratics. From this point forward, it's just expected that if I throw anything with a quadratic up here, you can handle it. Okay? Now, use it or lose it, right? If you're not using something, you're going to forget it. That's why I have open notes, open everything, because I don't think it's reasonable to have to memorize all that. Also, that's why you're going to start seeing more review of things on our quizzes. So we might be neck deep in logarithms in another 2 months. And I'm going to just randomly throw a quadratic at you and say, hey, graph this. Okay? So we keep reviewing it so we don't forget it. Now, it asks, what numbers are y values of the solutions, not just x's? 6 and 10. Well, you have to be able to graph these things. Do we got room? You know what? Instead of doing this one down here, let's come over here just so we got a blank space. Fresh start. They're pretty wimpy, huh?
Yeah.
I think I might have used a different, yeah, those are really wimpy. Do your best. Okay, start with 1. Graph the parabola, graph the line. Where do they cross? Okay, hash it out with your neighbors, especially if you're a little fuzzy on the whole quadratic business. Quiz over here. Thank you. That stack was just sitting over there. X is negative b over 2a gets a positive 3/2. Plug that in. Getting negative 9/4 plus 9/2, or 18/4 is 9/4, plus 2, so 9/4 plus another 4/4 is 13/4? Question mark? No?
I got 17/4.
Oh, it's plus 8/4. Okay, 17/4, yep. All right, we'll check it. My capability to mental math lately has been kind of rocky. Plus, oh, clear. Negative x squared plus 3x plus 2. Second, calculate a maximum because it opens downward. Somewhere between there and 6. 3/2, 17/4. Yep. Okay. So 1/2 and 1, 2, 3, 4, 17/4. From there, we'll move down in regular perfect square steps. Over 1, down 1. Over 2, down 4. Over 3, down 9, and on. So down 1, 2, 3, 4, 5. Down 1, 2, 3, 4, 5, 6, 7. Y'all notice that, right? That the perfect squares are in consecutive odd differences. Anyone? 1, 4, 9, 16, 25. The difference between them is 3, 5, 7, 9, and onward. It's handy for graphing because from here I can go over 1 and down 1, over 1 down 3, over 1 down 5, over 1 down 7. So the other thing I could do with it is try to find my X-intercepts. I could try to find my Y-intercepts. Well, Y-intercept is really easy. It's just at 2, which means if I go 1/2 that way, I can go 1/2 that way. You get this curve like so. Once I got to that one should be a lot easier. Start at 2, up 3 over 1, up 3 over 1, up 3 over 1, or down 3, back 1, down 3, back 1, down 3, back 1. Make your line. And it's a bullet graze at 0, 2. Got to be really, really particular with how you graph these. Because if you're not neat with your graphs, hint, hint, if you're trying to do your graphs on regular paper and you don't have immaculate handwriting for your assignment, this is not going to go well. Okay. Now, question. How did I get 0, 2 without graphing it 8 minutes ago?
Substitution, maybe?
If you look at the very next examples, right? Substitution, okay? Substitution and elimination is going to be, just like we can solve linear systems by graphing and then by substitution and then by elimination, I can also solve quadratic systems that way. Now, I got to double check our notes here because I don't think our book actually tells us the other way. Does it or doesn't it? Okay, no. They never talk to you about how do I do this by graphing in a calculator. Anyone catch that? All right, ladies and gents, head to Y1. Put in your first equation. Go to Y2, put in your second equation. When I graph, I see that bullet graze, right? If I were to zoom way in on it, in fact I can, zoom in, and I think it zooms in around, or it intersects around there. I'm just going to zoom in further. And I can keep zooming in and zooming in and zooming in and zooming in. And it's going to look like it just wings it. So to confirm that, just like I can find a post-traumatic stress response to that sound, I can also find an intersection. I can find a maximum, a minimum, a zero. We've done all that. Just find the intersection now. It's going to ask, first curve, make sure you're on the parabola. Poke. Second curve, make sure you're on the line. Poke. Guess. Okay, just tell me the answer. And it will tell you that they intersect at 0, 2. Okay? This is how you can confirm it by graphing. I want to make very clear that if it says solve by graphing, you will graph. Okay? If it says solve by graphing, you will graph. Yo.
May I have help with this calculator?
Ruh-roh.
My line looks like that.
That's because you're doing a different example there, dude. We're doing this one.
Oh, still? Gotcha.
Because we already know the answer for that one.
Gotcha.
All right? So, that's a way to check your work for graphing without actually having to physically graph. Quadratic systems by substitution. So this is what I did. Hey, get back here. This one. If y is this stuff, I jammed y with that stuff. 3x plus 2 is negative x squared plus 3x plus 2. Well, if I subtract 3x and 2 from both sides, and then square root, right? So I got x is 0. I plugged 0 in and said 3 by 0 is 0. 0 plus 2 is 2. Ta-da! 0, 2. You're like, wow, that's so much easier. Why didn't he show us that? Because you still have to learn how to graph. Or you have to remember how to graph. So, see it again. Because this one has more than one solution, as James just found out on the calculator. If I say that y is this stuff, I'm going to replace y with that stuff. X plus 3 is negative x squared minus x plus 6. It's a quadratic equation. How do I solve quadratic equations? However you want. It doesn't say how to solve it. You can get everything to one side and factor. You can complete the square. You can quadratic formula. I don't care. Now, personally, I just prefer. I'm going to bring everything over to the left here, getting a positive x squared plus 2x minus 3, because it's quite easily factorable into x plus 3, x minus 1, and I get set each equal to 0, x is negative 3 and positive 1. What you don't want to do, this is also the second time you've seen this, you did quadratic systems in Algebra 1, don't do freshman math and now say that. Bad. So if x is negative 3 and 1, I have to plug both in to get the y's that go with them respectively. Okay, I have to now say that y is negative 3 plus 3 and y is 1 plus 3. Getting 0 and 4. Now write your actual answers. Don't just quit. Say at negative 3, 0, right? Negative 3, 0. And at 1, 4. Okay? Life advice, if you have an x, you better find out y. If you have more than one x, you better find more than one reason why. Okay? So, your turn. If y is this stuff, replace y with this stuff.
I have more in here that I haven't eaten yet. More fruit silos and Starburst and...
No, I think in memes. So I'm going to have a picture of that above is it Shao Kahn? From the old Mortal Kombat movie in the 90s. It has begun! That's what I mean. It's not even Halloween, and you're already sitting over there with a pile full of wrappers. Look like a raccoon. Just like...
Teamwork inspires execution. Error.
All right. Quadratic formula, here we go.
Okay. Step 1. Replace y with junk. Replace y with junk. Get everything to one side. Combine like terms. Factor. Set each equal to 0 and solve for x. Once you got x, go find out y. And I'm plugging that into the linear equation. I could plug those into the quadratic if I wanted. Because it's supposed to solve, it's supposed to be a solution for both. Right? I could put the 1 in here, and I'm still going to get -1 minus 3 is -4 plus 10 is 6. Okay? I still get that same answer. What is Chad's question? Factors of -5 that add up to 4? Yeah? Can I who what?
It this way, and I got x plus 5, x minus 2. But when I did it this way, I got the right answer. I don't know how I got 2
But you set those equal to 6, not 0. Where did you get, or what is this?
0.
You can't just set it equal to 0. It doesn't equal 0. It equals this.
Okay, I see.
There you go. I know when you see a already factorable quadratic, you just kind of want to go for it. It's like the Marshmallow Test of math. Y'all know the Marshmallow Test, right? All right. The Marshmallow Test. And I got the perfect group for it too. Rolos. You love Rolos, huh? Okay. Okay. Who over here is the most impulsive?
Me. Yep. Told you.
Cool. Leave that there until the end of class. If you want, you can eat it right now. Then you have one. Like, you can just have it. But if you leave it there,
You'll get another one.
there'll be another one. Okay. Take the wrapper off. Take the wrapper off. It has to be in sight and clearly edible right now. It's called the Marshmallow Test because psychologists have done this with children for a long time. They'll take a marshmallow and they'll put it in front of like a 3-year-old and tell them, you can eat this if you want right now, but if you don't eat it for 10 minutes, I'll give you 2. And the vast majority of children will be, or they'll just forget about it 2 minutes later. So, we'll see. Has to be in sight. You can't hide it. You can't hide it. Got to be directly in front of you. Okay. All right. Solving quadratic systems. Okay. If I've got a quadratic with a quadratic, the same thing can happen where here's parabola number 1. Here's parabola number 2. Frank? They could intersect in one spot. They could intersect in 2 spots. they could not intersect at all. Okay, Frank is cross-eyed again. Been having problems with Frank today. Like, in the middle of what I'm doing, it'll just shift the input over 2 inches.
You ain't taking it.
There we go. Okay, now the marshmallow test works well on an individual, particularly one who has impulse control issues. Here's the fun part.
Wait, we can all eat it? All 4?
If a person eats that right now, you get it.
Yeah. Dude, I don't want to. I'm trying to get you.
If you leave it there until the end, everyone at the table gets one.
Everyone at the table gets it. Yeah. If you just take it, I still get one. Well, I get one either way.
James didn't even last to the end of the sentence.
He just ate it. We all are getting it. Don't eat it. Bro, leave it. No, you try to take it. We won't.
Sociology is fun.
This is actually. I get it or no raindrops. Either way, yeah. We all get one.
There we go. Now it's working. Okay.
One more try.
All right.
One more try. Okay. Don't take. Let's get this done. Calm down.
Hey, let's math now. You're going to get the assignment no matter what. Like, I'm not letting us get all the way derailed again. If y equals stuff, replace y with stuff, right? Or another way to say that, do you remember from back in geometry, something called the substitution property? If A equals B and B equals C, this is called the transitive property because you're actually cutting across the transversal, across the equal sign. Whereas if they're on the same side, it's called the substitution property. Okay? But either way, you set them equal, right? If they equal the same thing, then set them equal. So I've got x squared plus 7x plus 12 is negative x squared minus x plus 12. We're getting there. If I subtract 12, if I add x, if I add x squared, I now have 2x squared plus 8x is 0. Okay. Caden asked the question, could I do elimination? Look at what I got. If I wanted to do elimination, what would I have to be careful about? What do I need to do? They don't just eliminate right now. Y plus y is 2y. I negate one of them, right? So maybe I'll negate, 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 negate. Because I took that whole line times negative 1. And now, x squared plus x squared, x plus 7x, negative 12 plus 12. Oh, look, it's the same thing. Okay? So you can do substitution or elimination with these. Also, I'll go back a slide. Y'all can do elimination with these as well. Negate, 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 negate. 0 is a positive x squared. 3x plus x is 4x. Negative 10 plus 5 is minus 5. Isn't that exactly what we had? Okay, so substitution and elimination, you get your choice. You kind of beat me to the punch there. So, I do this and get 0 is 2x squared plus 8x. How do I factor that? Even better. You see how there isn't a constant term right now? The first stop on the factor train is to look for a GCF. What do they have in common? Not just divide by 2, but factor it out. Why don't I just want to divide by 2? You still have x squared plus 4x. You still have to factor. I also don't want to divide by 2x and then just make the x disappear. You would have a 0 over x over here. And that would just kind of mess things up. But set them both equal to 0. 2x equal to 0, well, x is 0. X plus 4 equal to 0, negative 4. Okay. Kids have a tendency to overthink these ones because they expect you have to do the full process like we do with other problems. No, just factor out the 2x and, oh, look, it's 2 factors. Set the 2 factors equal to 0. But then I have to plug them back in. And it doesn't matter which equation you plug them in either. You're going to get the same answer. So some people would go for this one because it's got smaller numbers. I'm going to prefer this one because of the positive coefficient. And say 0 squared plus 7, 0 plus 12. And negative 4 squared plus 7 by negative 4 plus 12. Plug in a 0, I get a 12. Plug in a negative 4, we get negative 16, negative 28, negative 44. Plus 12 is a negative 32, question mark? Oh, that's right. Womp womp. 16 minus 28 is negative 12 is, oh, that's 0. So 0, 12, and negative 4, 0. No, that's me did goof.
Caden has 4.
3. So, just like the other ones, substitution or elimination, your choice. I want you to do both because they both got a little different flavor to them. Literally a very different flavor to them with one little tiny detail. What's the difference between A and B? Just a negative. Watch how that changes your solutions. So good.
That's why is so good. Yeah. That's because you were sick. I made 0 and 2.
I'm telling you, elimination.
Don't move. Whoa.
It is better. So that's why. Because I'm getting that. It's -5.
Yes.
Go to bed before 11. Oh, I thought there was a...
Top on that. Negative plus negative 6.
You got negative 1.
Divide all 4 terms by 2. Make life easier.
You do the negative on the top one instead of the bottom one, so these cancel out. Then negative plus negative -5.
I went to bed at 1 in the morning, and I've never been so awake during the day. But then at night, I fell asleep in psychology. And I went to bed at 11. And I don't understand.
Never done it. Except for psychology.
I was so awake today.
Which is a bummer because psychology and sociology should be like the most fun classes in the building.
It was really fun, but
It's not what they want.
it's right in C's class.
Yeah. Also depends on presentation. If you got a teacher who's like, lights off, here's a PowerPoint, just copy stuff while I drone on for the next 90 minutes. Alright. It's another reason why I act like kind of a clown. I let my bouncing ball fly because human beings can't maintain concentration on something like that. Round 1. The first one I'm going to do by substitution. I'm going to say if y is this stuff, I replace y with this stuff. Negative x squared plus 5 is x squared minus 4x plus 5. I see a quadratic, so I'll get everyone on one side of the bus by adding x squared, subtracting 5, and that's all I got. I factor by GCF. And solve. Getting x is, set this equal to 0, set that equal to 0. Plug both of those back into the originals. I'm going to choose this one because it's smaller. 0 plus 5 is 5. Negative 4 plus 5 is uno. Getting 0, 5, and 2, 1. Contestant 2 I'll do by elimination. I will negate, and get 0 is 2x squared minus 4x plus 10. Divide everything by 2. Riddle me this, Batman. What factors of positive 5 add up to negative 2? Okay, I can't go straight for no solution just because it's not factorable. If it's not factorable, I need to complete the square or quadratic formula. So I'm going to say x squared minus 2x is negative 5. Add b over 2 squared to both sides. Well, half of negative 2 is negative 1. Negative 1 squared is 1. Getting x minus 1, the quantity squared, is negative 4. And what happens when I try to square root? You get an imaginary number. So that means there is no real solution. There is no place that these two parabolas will cross. As soon as I hit I, it's not real anymore. So there are no real solutions. As soon as I hit square root of a negative 4, the solutions for this thing are 1 plus or minus 2i. How can I graph 1 plus 2i as an x-coordinate on a real coordinate plane? So, no solution. Now, if you want to confirm that, you bring back your calculatron, go to y equals and say x squared, positive x squared, minus 4x plus 5. Down here, I've got a negative x squared minus 5. Parabola number 1, parabola number 2. They never cross, so no real solution. Show me some thumbs. How we feeling? I can do it. Substitution, elimination, graphing. I'm a little fuzzy. I probably want to do one of those again. Or, dude, what? Okay, couple of fuzzies. Was it the graphing or was it the substitution elimination? I know that we need practice with graphing. Like, that's literally what the entire math department is doing their SLOs on. Okay. The substitution elimination, how'd that go? Or do we need to probably one more? One more? Okay.
You put them into the equation. 0, square root of 0, plus 5.
That one. Try again.
So 2 squared. I can draw it 4 minus 5.
Question.
We have a question.
Only factorize the 2 here. Oh, no. And then complete the square.
What is this?
This, because I did not factorize the 10, so I leave it. And here, because I had 1 in the parentheses, so I added 2 to the whole thing, and so I subtract 2.
Okay, so you were completing the square in vertex form. But that's okay. You would have ended up with 2x minus 1, the quantity squared, plus 8 is 0.
Yes. So then,
Subtract 8. Get a negative 8, divide by 2, get a negative 4, and same thing that we just ran into, you're going to try to square a negative thing. No, you're sniffing down the right trail, you're just doing it a different way. Zoe went off-road.
Papi. Zoe feels different. You heard me.
Talk to your neighbors. Ask me, I'm coming around. What the? Oh. I honestly thought this was a old Tamagotchi.
oh, I have one of those.
Okay.
Last time, is it okay? So last time on this one, I got like the opposites, almost like the opposites of everything. Instead of like -4, I got +4 and -10. It confused me on what was going on.
Because you threw a random negative in there.
I was like, but that would change that.
So if this is positive, then you have 2x squared. I don't know why you have this at all. You have plus 4x, but you don't have it anywhere else.
Oh, I wrote that bad in there.
So we got a couple different problems that kind of ran sideways. That's why elimination really is easier. Because y minus y gone.
No, I would have just gotten like the opposite. It would have gotten like a -2x.
So then when you divide by the -2, it all goes away anyway, right?
Because that's what I was saying. I just got like the opposite.
Yeah, you just negate it because you're going to end up dividing anyway.
Okay, so I was right.
Yeah. Negate, 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 negate. Okay, instead of saying this stuff equals this stuff, when you do, you're going to have to subtract this over. So if you have to subtract it over, just negate one of the lines. -1 times the whole line. Because that still maintains a balance, right? Like if I took this picture, but then I threw it up on the board in negative colors, it's still you, right? So I'm taking this whole thing times a -1. Yep. Yep, it'll do the same thing. I'm going to divide everything by 2, because 0 divided by 2 is still 0. I'm going to factor, because it's nice and factorable. And set each equal to 0. X is 3 and -1. So if I plug those in, if I plug in 3 and negative 1 respectively, 3 squared is 9, negative 9. Plus 3 is negative 6. Plus 2. Negative 1 squared is 1. 1 minus a negative 3 is 1 plus 3, so 4. Minus 4 is 0. 3, negative 4, and negative 1, 0. Now, I want to show you a different way. Okay, way back here, along comes Zoe and says, she does this. Remember we just got done with completing the square and turning something into vertex form? Well, what's half of negative 2? Negative 1 squared is 1. So if I add 1 here, did I really add 1? No. I added 2. So I'll subtract 2 to undo that. Won't you still get to the same answer, though? It's just a different route. I'm going to add 8. Divide by 2. Square root. Add 1. 1 plus or minus 2. Getting 3 and negative 1. There are different ways to solve, and once we hit the quadratic, I don't care how you solve it. Complete the square, quadratic formula, factor if you can. You know what? You could jam it on a graph and find your zeros. I don't care. Have fun. Do it however you're going to do it. Okay. Y'all remember how to graph? What's different about graphing now? Instead of solid or dotted lines, now it's solid or dotted parabolas. And I have to shade. First one. I'm not sure what to make of the amount of chatter, because I doubt it's all about math. First quadratic, what's B? What's A? Getting a negative 9 halves. What do I do with negative 9 halves? Plug it in. F of negative 9 halves is going to be negative this thing squared minus 9 by that thing minus 2. Plug in negative 9 halves. Getting a negative 81 fourths plus 81 halves, which is 162 fourths, which is positive 81 fourths. Minus 2 is 77 fourths. Ew. I didn't again. I didn't have the 8 there. Right, 81 fourths minus 8. 8 fourths. There we go. That's twice in the same class I've done the same thing. No, because I didn't write it. Also, if I had to learn nonverbal language the hard way, then so do you. I said, is 77/4? And the change in tonality at the end denotes a question. Ha 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 ha, technicality. So, where do I put that? Is that even right?
Hope so.
Because that's kind of like big and stuff. That's 18 1/4.
Yeah, perfect.
Okay.
Yeah, there's 20. Yeah.
So -9/2. So 1, 2, 3, 4.5. 18 1/4. 15, 16, 17, 18 1/4. You can wing it. You see where the numbers are.
18 1/4.
Yeah, except there's nothing on just kind of catch.
Okay, we'll just go right to bed.
Yeah, you're gonna have to wing it. Perfect square steps, but they're all headed downtown. Right 1 down 1, right 2 down 4, right 3 down 5, or 9, but I'm doing 5 here. 1, 2, 3, 4, 5. Down another 1, 2, 3, 4, 5, 6, 7 over 1. Down 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm running out of space. Mirror across an axis of symmetry. That one goes over. All right, this one. The same area, because we don't actually care about the intersection points on these. It's a region. Solid or dotted? Right?
Oh.
Okay. And then, if you remember back to when we did linear inequalities, how do I know where to shade?
Well, there's two.
There's two ways. Option 1, just look at it. It says y is less than the parabola. So, less than the parabola. Option 2 says you plug in a point. Sometimes it's a nice easy point like 0, 0. Sometimes it goes through the origin. You have to use like 1, 0. But big whoop, you pick a number, a coordinate, plug it in, just see if it's true or not. Okay? The second one's a lot easier to graph. Why?
Because you just go down 2 and then just
Transformation form. My vertex is just down 2. And a value is 1, so regular perfect square steps. Over 1 up 1, over 2 up 4, and on and on and on. 2, 3, 4, 5, 1, 1, 2, 3, 4, 5, 6, 7, 1, 1, 2, 3, 4, 5, 6, 7, 8. Ah, almost. Had to go a little off-road. Solid or dotted? Ew. And that one says y is greater than the parabola. So we're going to shade above that parabola. And I have to find the region where both of them are going to be happy, and it's that little ellipse in the middle. This area right here. Okay. So we can do systems of equations and get intersection points, or we can do systems of inequalities and get shaded regions. Either case, you better know how to graph these things. You've done it enough times. We all good? Okay, since we used up that graph space, I think we're going to do that again. We're going to come back over here. These are nice, easy ones, though. Let's do something a little bit easier to finish off. I'm going to assume you know how to graph things. So, graph these two easy ones. Okay, I suppose I shouldn't say easy. How about these simpler ones?
That's not ideal. That's ideal. Motivation. They have like 3 more minutes. No.
Like, how do you, like that? Yeah. If a raccoon tried to eat your kittens, would you let it? Something like that.
That's a weird question.
No, I asked Zoe. Zoe said she would let it eat her child, but not her goat. And so did he. It's fine.
No, you didn't ask me that.
She's French. They're weird.
Okay, but I asked. It was like a like the perfect child. The one she loved. That she wanted.
Listen. You're supposed to leave your child in condition.
Yeah, but you would let
It doesn't have to be a child.
No, I had to explain it that way to Zoe.
Do the problem, please. There shall be no singing in my room.
At the table. What? That is not.
Yep.
You were singing too. Oh. I should have ate it. I really totally. That is so unfair. What? I had that thing that was just like that. I couldn't eat it. I don't know.
I'm kind of glad.
Singing makes me physically uncomfortable.
Really?
Yes.
I mean, that's a great reason.
It just does. It makes me cringe and squirm. Imagine taking, you know those slugs that if you squish them a little, they go, take that, jam it into your ear and grind it in. Now grab your eyelids and yank them off. That's how I feel when people are singing by me. So, we still have 2 minutes.
Oh, perfect. We haven't ate it yet. We haven't ate it, so we all get it.
So, this one I'm just going to say, how about like this? Maybe that helps us, that we're going to go up 6, and it's going to go downward from there. Solid or dotted? This one.
Dotted.
Shade up or down?
Down.
Okay, I'm going to show you a quick way to graph the other one. Zoe way. I completed the square. Half of -4 is -2. -2 squared is 4. If I'm adding 4, I have to subtract 4 to balance it out. That is now y is greater than x minus 2, the quantity squared minus 4. It's got a vertex at 2, -4. 2, -4.
Okay, I did do it. Almost
4, 5, 6, 7. There we go. And also dotted. Hey, here's another way. Isn't that factorable?
Yep.
Plot your zeros at 0 and 4. If I plot my zeros at 0 and 4, halfway between them is my axis of symmetry. Okay?
Oh, we were so close.
There's a bunch of ways to do it, but we did get there. Don't start on your assignment until I send it out on Remind, because I shall honor thy request. I am going to try to bring our assignments down.
So we never ended. Should we get started?
I told you to stop singing. You sang louder.
I had that the whole time. I was